So this is the kit we have to perform various experiments from electricity. Let us open the kit. What we have inside is these 4 foams with both side tape, bulb and bulb holder, cell holder, few nut and bolts, cells, a rheostat, nichrome wire wounded on a plastic strip, few wires with lugs, and most importantly we have this base on which we will be mounting all these material. So first of all we will remove this both side tape and stick it at the bottom like this. So I will do it for all 4 corners, and then let us see, we can use this as a base to keep it on any flat surface. After that we have to fix this sail holder. You will find nut and bolt. So this is basically a CSK bolt. If you don't get such sail holder with nut and bolt, simply you can stick this sail holder at this place. So I have this another sail holder. So you can just remove this both side tape and stick it here. If you get a sail holder with nut and bolt, then you can insert this CSK bolt through the hole from upper side, match the holes, and from the bottom side you have to put the nut, and later on we have to tighten this with the help of screwdriver. So first of all I am just putting both the nuts. And from the top side you have to just tighten it. Make sure that sail will go inside easily. After that, open this pouch. Take out all nut and bolts. You have to remove nut from all the bolts first. We have this metal strip with 2 holes at one end, and another metal strip is L-shaped strip. So first I am going to insert one long bolt into the metal strip. We will use this as a handle of a switch. Then remove these 2 nut and bolts. So first we will fix this onto the board. So insert from the bottom side and place, you will see switch putty is written there, and then put the nut on it. Don't tighten it too much because we need this movement to make it on and off. Similarly, we have to fix this L bracket on the L bracket switch using 2 short nut and bolts. These are M4 by 3, M3 by 5 long nut bolts, and this is M4, the short bolts. Match the holes like this, and from the bottom side put the nut. We will fix these nut and bolts using screwdriver. You can tighten it using screwdriver and holding the nut from the bottom side. So this L bracket will be fixed, and if you see, this is acting as a switch like this. Similarly, using remaining two long nut bolts, we have to fix this bulb and bulb holder. So insert, you have to attach this using only one long bolt. So insert it here, and from the bottom side tight it, put your finger and tight it from the top side. Keep it on the position. Similarly, remember we have to fix this bulb and bulb holder using only one long bolt. Insert this another bolt and keep it inside. You have to repeat the procedure. Put the nut, hold the nut from the bottom with your finger and tight it with the help of screwdriver. Now our basic setup is ready. Now we have to check both the bulbs if they are working or not. For that we will insert batteries inside the cell holder. Remember, on the spring, negative terminal of the battery will go, and similarly another side. Now take these two wires and take to the bulb. Now this bulb is glowing, so perfectly fine. Second bulb fuses. Now if you see, this bulb got fuses once I connected this here. So I will remove this bulb and will take another bulb. By any chance, if you see bulb is not glowing despite of connecting both the wires, so it may happen that this bulb is loose. So always hold the metal part of the bulb and tight it. Don't tight bulb using or holding the glass part of it. See, both the bulbs are glowing. Now we will make the first connection of a switch. So we will take wires, connect wire with switch. Just you have to loose this nut, insert this C bracket or C portion, loose this bolt, insert it there, and again you have to tighten it. After this, so here this is the simple circuit. I have connected one wire from the switch to the one terminal of the bulb, one wire coming from the battery with another terminal of the bulb, and one wire with this L bracket. Now this circuit is not connected yet, not completed. So if I take this switch and touch here, you will see this circuit is completed, and that is why bulb is glowing. So this is off position, this is on position, and this is the simple circuit. Now in this we'll see also conductors and insulators. So if I connect these two terminals instead of switch, if using screwdriver, so screwdriver is made up of iron and it is a good conductor of electricity. So circuit is getting completed and bulb is glowing. But if I connect these two terminals using any wood, you can see wood is bad conductor of electricity, so bulb is not glowing. I will try with the plastic as well. I am touching these metal brackets with plastic. Electricity is not flowing and bulb is not glowing. So again I will try this. So you have understood basically the conductors and insulators and working of a switch. Now we will make one more circuit, that is series circuit. Observe carefully. There are more wires in the circuit now, but previously this wire was there going from switch to the one terminal of the bulb. Now one wire coming from the battery is attached with this bulb, another battery is still remains the same point we used in previous circuit, and these two bulbs we have connected with this red wire. Now I will make this circuit on. See the intensity of the bulb. If you see this intensity of bulb, it is reduced than previous. We are using 1.5 and 1.53 voltage. Intensity of this bulb is reduced, but you will see intensity of both the bulbs is the same. Now I am going to lose one bulb, immediately another bulb also went off. Again I will make it on. If I do with the other one, the same results is coming. Such type of circuits are called as series. So we have connected bulbs in series. When you lose this bulb, actually circuit is getting break. Circuit is not completed. That is why both the bulbs goes off. After this we will make one more type of circuit, that is parallel circuit. Now carefully observe the wiring what we have done here. Positive from the battery is going to L bracket, negative from the battery is going to this terminal of the battery bulb holder. Then if you see it carefully, from the switch this black wire is coming here, we have attached one more wire. So in this we have two wires, and this wire is going to this black wire to the another terminal of the bulb, and here also at this point the negative terminal from the battery is coming to this bulb holder. So we have again two lux or two wires here, and this wire is attached to this another bulb. This type of circuit is called as parallel connection. So we have connected these two cells in parallel. Let us observe what is the difference between series and parallel. If you remember the intensity of both the bulbs in series connection, you can compare the intensity of the bulb in parallel connection. I am switching the circuit on. Surprised? What happened? The intensity of the bulb is more than that of previous circuit, because both the bulbs are getting 3 voltage independently. So even if you switch off any bulb or take out any bulb, still another bulb will go on giving us light. So such type of parallel circuits we use in our domestic, basically they are called as domestic circuits. Whatever connections we have in our house is parallel type. So even if you switch off the fan, your TV still goes on. Otherwise, imagine if you switch one thing, all rest will go off. What will happen in house? So such type of circuits are called as parallel circuit. After this we will see working of rheostat. Observe the connection carefully. I have connected this rheostat using nut and bolt to this L bracket. Positive is connected to L bracket, negative of the battery is connected to one terminal of the bulb, and another wire coming from the bulb is free. So if I touch the starting point, this point I will call as a starting point, and then this nichrome wire is going away from the starting point up to this point. So if electricity has to flow from nichrome wire, this is starting point, this is end point. So if I hold this as a starting point, and see the intensity of the bulb, it is high because right now electricity is not passing through the nichrome wire, because you can see here it is coming from the positive terminal and directly circuit is getting completed at this point. But if I hold it at the end, now see the intensity of the bulb. I will just insert it there so it will remain permanently on. Now in this position you must have observed the intensity of the bulb has reduced. Why? It is because of the electrons or electricity is passing through this nichrome wire, and nichrome wire has high resistance. So current flowing through the circuit is less, that is why intensity of the bulb is reduced. If you hold it at different points, you will see intensity of the bulb is getting reduced as you go away from the starting point, and it is minimum at the last point. This also you can use as a heater. So instead of connecting to the bulb, if you just attach this nichrome wire, I will just remove this so that there will be no confusion for you. Now as you can see, I have connected these two batteries directly with the rheostat. Here this is getting connected, and if you keep it for some time and try to hold here with your finger, you will see this has become hot. So this is the effect what we are getting, heating effect of electricity. So when electricity passes through high resistance wire, it gives out heat. This we called as a heating effect of electricity. So this all experiments you can perform using this material at home. Do send photographs of your circuits to us. Thank you.